This is my Makita router, more specifically the RT0701C compact router. 1.25 horsepower, 10,000 to 30,000 RPM, but I'm afraid I might have pushed it beyond its limit recently on a job I did, and it's been voicing its displeasure ever since. Internally, but loudly, and also emitting a weird sort of smell, which is a cross between ozone, hot carbon brushes, and melting plastic. And it's been stuttering too. Let me show you. Can you hear that, right? And that smell, just that little gray circle in the center of your screen, just give it a little scratch and move your nose to that. Yeah, that's the smell. It's a great machine and it's worth, it deserves a bit of love. So let's take it over there. For those unfamiliar with routers, they remove material, usually wood or plastic, but they're used mostly in woodworking, especially for cabinetry. I've never taken this tool apart, but I'm thinking the problems may be caused by the carbon brushes, maybe the bearings, or the motor overheated and there's some deposit or damage on the motor's commutator bars. Router bits, such as the one here, make cutouts, edges, they cut joints and create decorative surface cuts, and there are countless shapes and sizes of router bits. They're basically sharp, quick spinning knives or chisels. First, the carbon brushes. They're electrical contacts made from specially prepared carbon, and they conduct current to the commutator bars of the motor. Because they're constantly in contact with the motor's spinning central shaft, they wear down depending on how much the tool is used. Those little caps I'm unscrewing allow the user to quickly access the brushes for maintenance. This Makita has 4 tapping screws holding the body together. The other shorter screws hold the string relief. This sealed unit, this black box, is called a controller. There are slots on opposite sides of the housing, just big enough to slip in a flat screwdriver. From there, it's prying and jiggling with any tool which works. Unscrew the collet nut and pull out the 1/4 inch collet cone. Right here, there's a section of the commutator bars which has been damaged. Maybe by a short, maybe by overheating, or both. This gives you an idea of how the carbon brushes make contact with the commutator bars to transfer current to the electromagnet windings. One large ball bearing and a small one. They both seem to be spinning freely. That's carbon on the commutator bars. It's a deposit. And now on my fingers. One way to restore those bars is this. Like new. There are 3 tests to perform with a multimeter to know if your armature and windings are damaged. The first is called the 180-degree test. To help me with the first test, and because my fingers are so big and clumsy, I'm marking a first bar and going around marking every second bar with a Sharpie. There are 24 in all. Now I need to test the resistance at completely opposite sides of the assembly. If you've ever wondered what these notches are, they're ground out during the manufacturing process to perfectly balance the weight of the armature assembly. So, set your multimeter to the lowest resistance setting. You'll be using that ohm setting for the following two tests. Test the resistance between commutator bars on completely opposite sides. The measured value isn't important, but it should be consistent as you go all around. A sharp drop in resistance could indicate a short between the wires of the windings, and a resistance spike tells you there's probably a broken or burned wire. The second test is called bar to bar. You test neighboring bars with the same meter settings as the first test, and the reading should be consistent all around, without the drop or spike in value. Incidentally, bar to bar is a technique my girlfriend and I use after a day of touristing, which is usually wandering around a foreign city. As we absorb the local culture and food and drinks and conversation, we'll walk out of one bar, pub, cafe or terrace and spot the next one across the street. In French, we say to one another, "Hey, un beurre." Yeah, we started calling them burrs for some reason, as we happily walk hand in hand into our next adventure. That's, anyway, the bar to bar test isn't detecting anything wrong. Third is the continuity test. Set your meter to continuity or the lowest ohm setting. Touch one lead to a commutator bar and the other to the armature stack. You should never have electrical continuity between the two. Your meter should show either 1 or OL for open loop. This too, all good. Slip the armature assembly back into the outer housing with a little smack or two to get it wedged tight in there. Assemble it all, you know how the rest goes. I think this is better now. There's less of that stutter. It feels different. Works well. I just have to be careful with it, not overdo it. Because it is a very nice, handy machine. It feels really good in your hands. Just got to keep your fingers away from all these spinny bits that'll just rip your fingers right off.